In this part of the lesson, we are going to talk about algorithm efficiency. So, to begin, I want you to write in the Unit 3 discussion board. Okay, I want you to start your post like this: U6L2. Warm up. Okay. And then you can just start writing. Have you ever lost a pencil in your backpack? What are the steps you take to find the pencil? Pause the video here so you can go to the discussion board and put your response to this. So what I do whenever I lose something, whether it's in my backpack or my purse, what I do is I will look through every pocket, and if I can't find it, I will take everything out and line it up. Okay. Some of you may have a system where you place your books and materials in your backpack to be retrieved in the order of the class that you're going to next. If you look in your book bag and at a certain spot and you don't see your pencil, then you have a pretty good idea of where to search next. The best part about these prompts is that there's not usually a right answer, because everybody has different approaches of doing things. There's not a right way or a wrong way. There may be a more efficient way, but that doesn't mean the other way is wrong. Okay, there are many different ways to achieve the same goal for this problem of finding your pencil. And what we're going to do in this lesson is explore different search methods that computers use. So, let's see. To do this, that's not what we need. To do this, we are going to look at the activity real quick. So you would need your journal and you would need some sticky notes. So if you have some sticky notes, you just have a little pad of sticky notes, okay? Now that you have your journal and your sticky notes, something to write with, I want you to write down okay, so I am going to, not that, what am I doing? Okay, so what we're going to do is on my sticky note, okay, I've got a sticky note and I am going to I am going to write down a number from what? My number is going to be from 1, nope, it's a number between 0 and 999. Okay, I have written this number down. Trying to make sure you can't see it through the paper. Okay, I have written this number down, and you are going to try to guess it. All right? So, what you can do is go to code.org, Unit 6, Lesson 2, and this is what we're looking at. I'm going to make it smaller so that way it fits. Okay? All right. So this is our ticket generator. And what we're going to do is you're going to hit run and you're going to click get a ticket, and it's going to give you a random ticket number. Okay, so for example, I clicked and my current ticket number is 294. That's not what's written on here. Okay, so I want you to generate 3 random ticket numbers. All right, and then I want you to go to the Google form that is linked in the assignment post, and individually I want you to type in those your 3 numbers. Okay, so you see how whenever it has 2 digits, the number can be 0 to 99. Okay, so you're going to get 3 numbers, and then you're going to put them into the Google form and see if you got the correct number. Okay, so how many steps are we following in order to find out if somebody has a winning ticket? What is the greatest possible number of steps it could take for us to do this? So if we have 3 random numbers, get your random numbers, go to the Google form, check to see if they're correct. So that's the greatest number of steps right now. But what if we were choosing 6 random numbers? The greatest number of steps would be 6. So this pattern of the number of steps and how many numbers we're trying to get, it is a direct relationship of 1 to 1. Okay, so the number of tickets in the raffle exactly equals the number of steps it would take to check for a number in, okay, so let's look at what this might look like. Okay, so I'm going to pull up, I don't have a whiteboard. Okay, so I'm just going to pull over this Word document. So this is just going to be kind of like scratch paper for me, all right, so that y'all can see what I'm doing. So if we're talking about this 1-to-1 relationship, if I can spell. Okay, so we said 3 tickets. There were 3 steps. We said if there were 6 tickets, there would be 6 steps. So however many tickets we have, there would be the same number of steps. And that is the most important thing for you to understand right now. Okay, so I'm going to move that aside, and we are going to try a different way to search. Okay, so let's see. Okay, so what you're going to do is you are going to, in the assignment post, download the digital manipulative. Okay, it looks like this, and whenever you click the link, it should, I'm going to make a copy. Okay. After you click the link though from Schoology, it should ask if you want to make a copy, and then you just click yes. Okay, so what this is going to do, go to code.org, bubble 1, okay, and you will generate 7 new numbers. Write those down, okay? 7 new numbers. So I'm going to do this also. I'm going to get 7 numbers. Okay, so I have my 7 numbers. Now what you're going to do is go to your copy of this. Okay, this is just a sample. It's giving us an example. So now what you're going to do, you're going to spread all these digital sticky notes out. Okay, you're going to put, man, it takes forever. So one thing I think that you can do, put one on that end, put one on the other end, and then select them all. Okay, and then you can say format options, position from top left, center. Yeah, I know. I feel like that's definitely not right. Okay. Well, oh, here we go. Align vertically along the middle. Okay. Well, that did not quite. Oh, distribute horizontally. There. All right. Now they're all lined up. Okay, so what you're going to do now is put your numbers on here, but list your numbers numerically. Okay, so I'm going to also do that. I'm looking at my list, and I'm going to put them on here numerically. So smallest on the left, largest on the right. Okay, I got my numbers done. If you still need a minute to put your numbers in, then pause this, okay, until you get those finished. Now, what we're going to do next is, let me get to the part where we actually are. Okay. Use the ticket generator to generate 7 tickets. You did that. All right. Write down the numbers on a virtual. You did that. Organize them numerically. You did that. Copy one of the numbers onto a separate sticky note And this is the number you're searching for. Okay, so go and choose one of these. I'm going to choose this one. This is the number I'm searching for. Okay. Now, create an algorithm to determine if a given number is in a list of sorted numbers. So you're going to write an algorithm, and these are your rules, okay? The search can start at any of the sticky notes. You can jump over sticky notes. So you don't need to search the sticky notes in order, all right? You can determine which sticky notes to search next based on the current sticky note you are checking. The goal is to make the determination in the least steps possible, but don't forget your number could be anywhere in the list. What is the greatest number of comparison steps it would take to find any number in your list using your current algorithm? All right, so remember, when we had 3 guesses at the beginning, it only took 3 steps. When we had 6 guesses, it only took 6 steps. Okay, so now how many do we have? That's many, okay? So your algorithm that you develop for this should only have 7 steps, okay? So pause the video here and see what algorithm you can develop for determining if the card you chose matches one of these other sticky notes, okay? So I am also going to work on an algorithm. Because mine are already lined up, this is how I'm going to go. I'm going to say, does the first number match the winning number? Yes or no? I think I'm going to write it. Okay. Does the current number match the winning number? Okay. Now, look, I'm about to be extra, okay? So this shape, I'm going to give it an outline. Okay, and then I'm going to say, I'm going to add a line, 2 lines actually, because this question, does the current number match the winning number? You only have 2 options for your answers. It's either yes or no. All right, so this side is yes. All right, and actually, let's put that in a triangle. Okay, I'm going to put triangle, double click, and I'm going to say yes. Oh, that's horrible. Maybe we should make the font smaller. Yay, now you can't even read it. Okay. I think you point it down like that. Fantastic. Okay, so yes, and then we need one for no. Okay, so now what's going to happen if it matches? you stop. Okay, it's not super complicated. Your whole purpose that you're trying to do right now is trying to match the current card to the winning card. Okay, so what are we going to do if it does not match? We're going to move the winning card one spot to the right. Yeah? Well, at least that's what I'm going to do. You may have chosen a different method, and that's fine. All right. So, let's follow this. Compare. We've got to compare the numbers. Okay. All right. Compare. Does it match? No. Move the winning card one to the right. Compare. Does it match? No. Move the winning card one to the right. Compare. Does it match? No. Move the winning card one to the right. Does it compare? Does it match? Yes. Stop. All right. So do you see how we did that? How many times did we go through this algorithm? 1, 2, 3, 4. So this fourth time is how many it took for us to do it. So that is how this is called a search algorithm, where we go through this algorithm and we are searching for something. So this particular search algorithm is known as a binary search. And so what we're going to do is we're going to see it in action. So let's go back. Okay. This is our binary search. So let me see. Okay. I think I have to present it. So let's see how we're going to make this work. Okay, so I want you to try this algorithm and see how it compares to your algorithm. All right, find the middle number in the list. What was mine? What was my middle number? Okay, my middle number. Okay, that was my middle number. So I'm going to pretend that my winning number is 281 instead. Okay. Find the middle number in the list. Compare that number to the given number. If the middle number is less than, remove all of the cards to the left, including the middle number. If the middle number is more than, remove all the cards to the right, including the middle number. All right. If it's less than, it's not. This card in the middle is more than. So what we're going to do is we're going to remove these. Okay. Now, find the middle number in the shorter list. Okie dokie. Follow the instructions in step 1. Compare the number to the given number. If the middle number is less than the given number, remove them all to the left. It is less than, so now we have to remove these two. All right, and now we go to the middle. and compare the number, and that's good. So that was only a 3-step algorithm, whereas the one I originally came up with was 4. So, wow, all right. Now, let's look at this binary search. Okay, so we've been talking about how we have different types of searches. And this particular search algorithm is called a binary search. So we have our winning card, 705. We're going to put it in the middle and compare it. 705 does not match 410. It's greater than. So we're going to move it to the right. We're going to put it in the middle of this group. 705 is less than 716. So we're going to get rid of 716 and 833. And now we're going to compare it to this one. And we have our match. So that's 3 steps. So the binary search algorithm for different instances. Okay, so we know for 7, the shortest number that we can do is 3. We've done a few, Code.org has done a few of these instances for us, and we can copy these in our journal and plot the points on the graph. Okay, so instance 1, instance 3, instance 5. So go back through. Okay, I'm going to delete some of my... Actually, I'm not going to delete it. What I want you to do is I want you to duplicate that slide. Okay, and then you can delete this stuff. All right, and we're going to redo some of these, but with the different instances. Okay, so I want you to put your instance number seven. All right, and then again, because you're going to have to start at 1. How many steps does it take? Okay, so go through that, and whenever you get done with this chart, what you can do for this is I gave you a link to these slides in Schoology. So you can make a copy of these slides, and then you'll be able to edit the slides, and you can put numbers in, and you can also copy and paste these dots to put them where they need to go. All right, and then that's going to be one of the things that you submit is this screenshot. Okay, and so this is a screenshot of slide 20. Really? Okay, so let's compare a linear search with a binary search. Linear search is where you go just straight down the middle, right? You just follow in line. Binary search is where you go through sorted data, and it's faster than a linear search, but it still takes a long time. So here's our 2 searches. So here's our 2 searches. The first search is a linear search. As we add more inputs, the number of steps grows at the same rate. And the second search is a binary search, and it grows at a much slower rate, but it is faster than a linear search. So a linear search is 1-to-1 every single time, okay? As the number of instances go up, so does the number of steps. Binary search, it's a very slow curve. So that's a good thing. One thing that we're going to do is, before we move on, I want you to pause the video and complete this table. Okay, pause the video and complete this table. I already showed you what the binary search is going to look like, what that curve is going to look like. It's not going to be a straight line, so it's going to be a curve, and so you kind of have an idea about where things are going to go. So for your first instance, you have one input. How many steps? One step. What about 3 inputs? 2 steps. For 5 instances, you have 3 steps. We already know for 7 instances we have 3 steps, and for 9 inputs, we have 4 steps. And that gives us that binary search. So another way of thinking about this is looking for the pattern. How many bits does it take to represent 1 in binary? What about 7? And what about 15? In our next lesson, we're actually going to make a little binary type calculator thing so that we can convert between binary and decimal numbers. So it takes 1 bit to represent the number 1 in binary. It takes 3 bits to represent the number 7. And 4 for 15. And we will get into that. And so for your last, okay, if I had 1 input, which algorithm would I use to get my answer with the fewest amount of steps? Would you use a linear algorithm or a binary, like a linear search algorithm or a binary search algorithm? All right, and that's with just 1 input. What about 5? What about 100? So create a table for your instances. Okay, 1, 5, 100. And put down the number of steps and submit your table to Schoology as one of the documents for this lesson. Then I want you to add these items to your journal where you have all of your key vocabulary.